Welcome to part 2 of our limiting reacting notes. In the last video, we started with moles and we ended with moles, so there wasn't much that had to be done, and that was just to show you how to use the BCA chart and how to convert and figure out which reactant is our limiting reactant, which one will we run out of first. Well, in this case, this is going to be more of a real-world scenario. In the real world, I'm not going to measure moles, I'm going to measure grams on a scale. And so maybe I have a certain amount of reactants and I want to make as much product as possible. So I want to know, with my 18.23 grams of sodium, how much, and 34.85 grams of chlorine, how much salt can I make? Well, one of these is going to run out first, and I need to figure out which. So I'm going to do my BCA chart. But before I do my BCA chart, anything that goes in your BCA, sometimes I'll call this BCA chart your mole table, because only moles can sit at this table. No grams allowed. So since the only thing that can go in this table is a mole, that means I can't put the grams in there. Moles only. With that being said, that means I need to convert my grams to moles. And so I have 18.23 grams of sodium. And I know that the molar mass is 22.99 for sodium, meaning that there is 22.99 grams of sodium in every 1 mole of sodium. Calculate that, and that's going to go ahead and give me my moles of sodium. And so I have 0.79 moles. Now, just as a quick reminder, because sometimes we will have very small numbers, less than 1, we will round to 2 digits, but they have to be 2 non-zero digits. And so what do I mean by that? Well, if my answer had been 0.0013, I'm not going to round it to 2 digits because that would be 0, and that doesn't make sense. That's not what happens. If I round it to 0.001, well, that's not giving a full picture, and that's still a lot of particles I'm leaving out, especially if maybe this were 8, then that rounds to almost 0.002. And so I want to account for those particles, so we're going to round to 2 non-zero numbers. So going back to our problem, I now know that I have 0.79 moles of sodium. That's going to be my starting amount of sodium. So I'm going to go ahead and fill that in my chart. Now for my chlorine. My chlorine, I have 34.85. Keeping in mind that this is chlorine, Cl2, when I do my molar mass, I need to do the molar mass of Cl2. And so since 1 chlorine is 35.45, 2 chlorine is going to be 70.9. And so I'm going to take 34.85, divide it by my 70.9, and I get that I need 0.49 moles of chlorine. Again, that's going to go in my starting point because that's how much I have at the start. We're not done with moles yet. Remember that we need to use our moles to determine which one is going to run out first. I'm just gonna, I'm just going to shrink these and move them out of the way so they're still there, but so that I don't have to have my math all over the place. And so with this now, I need to figure out if I were to use all of my sodium. Oh, before I do that, I'm going to have to compare my moles here. And so I need to have a balanced equation, because remember, we're going to use the coefficients of our balanced equation to determine how much of each we're going to need. And so with that, I know that for every 1 mole of sodium, not 1 mole of sodium, for every 2 moles of sodium, I need 1 mole of chlorine to produce 2 moles of sodium chloride. And so to start, if I use up all 0.79 moles of sodium, how many moles of chlorine would be needed? And so I'm going to sit there and look, and I'm going to say, okay, well, if I have 2 moles of sodium and I have 1 mole of chlorine, that means that for me to use all of my chlorine would require 0.395 moles of chlorine. And so if we want to round this to 0.40, that's okay. 2 non-zero numbers, and so I'm going to round. Those 2 aren't 0, so 2 non-zero numbers. So since I need 0.40 moles of chlorine and I have 0.49 moles available, that tells me that sodium is in fact my limiting reactant. As far as my product in the before, remember, this is before the reaction, so we have 0 product that has been formed. My product is always going to be 0 moles to start because it's before I did the reaction, so I can't have any product. For my change, remember that I'm going to use up the reactants, so my reactants are going to be subtracted. In this case, I'm using up all of my sodium. Since I'm using up all of my sodium, that means that my after is going to be 0. I'm using it all. Nothing left. My chlorine, when I used 0.79 moles of sodium, I used 0.40 moles of chlorine. So that means that I will have 0.09 moles of chlorine remaining. As far as my product will be a positive number because I'm producing it. I'm making it. And so I can do a cheat here. If you want to go ahead and do the mole ratio conversion, that's perfectly fine. But I can see that my coefficients match. Since my coefficients match, that tells me that the moles of sodium I used will be the same amount as the moles of sodium chloride produced. And so I end up with 0.79 moles of sodium chloride. We're not quite done yet because the question asks, what is the mass of sodium chloride produced? And so I need to do one more problem here. I now need to take my 0.79 moles of sodium chloride and I need to convert it to grams. So for every 1 mole of sodium chloride, I have, sorry I don't have this calculated out ahead of time. And so I'm going to have 58.44 grams of sodium chloride for every 1 mole of sodium chloride. And so that means that I will have produced 46.17 grams of salt. Hopefully this helps. If it did, make sure you click the like so that I know it's worth it.